assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
So in this problem, we have the reaction C solid plus H2O gas reversibly forms CO gas plus H2 gas. And we know that Kc is equal to the concentration of CO times the concentration of H2 over the concentration of H2O. And so the first thing we can do is find the molarity of water, and we do that by doing the ideal gas law, PV over RT. And so we're given a pressure of 145 torr, multiply that by our volume, 1.55 liters, divide that by our gas constant, which in this case is 62.36367, and that's in liter torr per mole Kelvin, and that is just to cancel out our other units, and then multiply that by our temperature, 700 Kelvin. And that gives us 0.005148 moles of H2O. If we divide that by our 1.55 liters, we get 0.0033 molar water. And so now we can set up an ice table. So we ignore C since it's a solid, so we just have concentration of H2O, concentration of CO, concentration of H2. Our initial, our change, and our equilibrium. Our H2O, we know, starts out at 0.0033 molar, and our products start at 0. Here we have minus X, and plus X, since the mole-to-mole ratios are all 1. And so we have 0.0033 molar minus X water, and then X of CO and H2. And so now I'll go to a new page here and we'll come back to this. We're given a Kp, but we want Kc since we want concentration. And Kp is equal to Kc times RT over delta N. Therefore, Kc is equal to Kp divided by RT to the delta N. Our delta N here is 1, since we have 2 moles of product and 1 mole of reactant gas, that is. And so we can plug in our values here. We have 1.6 times 10 to the negative third for Kp, and 0.0821 times 700 Kelvin to the first power. And so our Kc is equal to 2.78 times 10 to the negative fifth. And so now we can plug that into our Kc equation, 2.78 times 10 to the negative fifth, and that equals our concentration of CO, which is X, our concentration of H2, which is X, divided by our concentration of H2O, which is 0.0033 minus X. And so now we want to solve this equation for X, and when we do that, we get that X is equal to 2.893 times 10 to the negative fourth. And so now we know all of our equilibrium concentrations. And so our concentration of H2O at equilibrium is 0.0033 minus X, so minus 2.893 times 10 to the minus fourth. And therefore it is 0.00301. Our concentration of CO is equal to our concentration of H2, which is equal to our X, 2.893 times 10 to the minus fourth. And we want to find what percentage is H2. And so to do that, we want to find the total. And so the total is equal to our 0.00301 plus 2 times our 2.893 times 10 to the minus fourth, once for CO and once for H2. And that gives us a total of 0.003589 molar. And so now if we want to find percent H2, we just take our 2.893 times 10 to the minus fourth, which is our H2, divide that by our total, and multiply by 100, and we find out that we have 8.1% H2, and that is our final answer.